Okay,
Professor,
right. Go ahead.
Professor, I have a question.
Oh, I cannot hear you. It's not clear.
Yes, can you hear me, Professor?
Okay, go ahead and
I have a
say.
question here.
Go
So,
ahead and say
are we
again.
reducing the non-response or adding the
Adding.
non-response to the?
Yes, yes. Non 20% non-response. You add to based on
Professor, are
484.
we adding the
We
non-response
Adding. Yes.
percentage or no? We are
Add.
reducing it from the
Okay,
total.
okay. You add. You add 20% as a non-response. That's
so
true.
Professor,
basically it's like
are we adding the non-response or reducing?
How you reduce? It's not reduced. You can see that, right?
we can do like 20 divided by 100 times like 484, we'll get
Yeah.
one particular number plus 484, then we will get like 581.
Yeah.
So, Professor, I had a question.
Yes, sure.
Professor, this non-response rate, it basically depends on the primary researcher, the one who is conducting the research, right?
No,
Like we are.
yeah, non-response is like based on it is something you can decide by discussing among other researcher, or if for to faculty, or someone conducted a research in the same setting, so they can tell you about this non-response. But in the safer side, it's like a 20% is something, is a
That's a
kind of a
standard.
custom to add 20% extra. But
Okay, okay.
20% is something you don't have to achieve. As I said, if you think, if you reach to your calculated sample size 484, you can stop there by taking maybe 10, 20 extra, because there's something that you need to delete because of incomplete response. Sometimes people stop at the halfway, so you have
Yes.
to exclude them
Just to
from your
stay on the
final
safe side.
final
Right, right.
analysis, right? That's why you take some extra. So this 20% is like in your planning stage, but in actual, during actual data collection, if you reach to 484, then yeah, you don't have to go 581, right? This is
Oh, okay, okay.
something, yeah.
So my question was that
Professor,
there is no like mathematical formula or any way to determine. It's just up to us
up
that
to
we
up to
consider
That's
20 or
true.
10
Yeah,
or
that's
more.
true.
Okay,
So
okay.
in some society, some culture, some community, this 20% can even go up, because as I said, in some community or some society, people don't want to participate, very reluctant to participate in research. In that case, this 20% can go to 30%, 40% even, right? That you need to approach many more people in order to get what you want to get, right? Yeah. Okay. So we are done with here. So like, should we try the next one as well? So, the
Yes,
two.
Professor.
Yeah,
Yes,
second one.
Professor.
Yeah, try the second one
Yes.
also. Second one,
Professor,
you need
a
to
question.
select a different formula. The next one.
Yeah.
Yeah.
So power is the level of confidence, right? And 5% level of significance is the same of 5%
Alpha.
precision.
No, not the
Uh,
precision. 5% level of significance is like uh, uh,
Alpha.
Only alpha.
yeah, yeah,
Alpha, yeah.
alpha. Yeah. So let's see the. So here you see that this prevalence P, 2P, one is like P1 and P0, P0 and P1, right? Find that formula where there is an example about, what is the example there? So you see the smoking was reduced from 25% to 20% among teenagers because of something has been done to giving education. I mean, project is planning to give some education or knowledge so that the smoking rate from 25% reduced to 20%. So if this is the case with 95%, 90% power and 5% level of significance, how many teenage people you need to include in your research? I cannot hear who is telling to say something. Amal, Ashlin,
It's not me, Professor. I guess
Khadija, I guess.
Khadija, it is.
Khadija.
Yeah.
Khadija, your internet is a problem. So
I guess she
yeah,
can
no, we are
write it
so
in the
sorry,
chat box.
Khadija. So sorry. Write in the chat box. Yes, yes. Type in the chat box. What? Yeah, we are really, really sorry that the internet is a big
Professor,
problem there. Right.
for this wish formula, there is one formula, but it required like incident rate, which can, but I don't know which formula to apply there.
So find out the formulas and don't go that far. So where you see that the prevalence changed because of some work that they have done. So which one?
Professor, is it the n equal g1 minus alpha root over not 1 minus not?
Is it the
That one?
hypothesis test, Formula 1?
Yeah, I think so
Like for
because
two-sided.
yeah,
Which
two-sided
is,
one.
oh,
Like
okay.
there is
For
one.
two-sided. For
Yeah,
two-sided.
What
Yeah.
Z 1 minus beta?
yes, and then
It's
you know that there have been there is one example of dental caries among children, right?
Oh, okay, got it.
Previous
Yes.
survey have
In
demonstrated
page
that
number 22.
prevalence of dental caries among school children is 25%. So how many children should be included in a test to decrease the prevalence of dental caries after an intervention? If the desired 90% sure, the detecting a rate of 20% at the level of 5% significance. So 90% power. So the example is that one.
Professor, I have a question.
Yes.
How we can select the power of the test?
Power is already mentioned here, right?
That is 90, right?
90, yes.
Okay.
90%.
Mm.
But the power is 90% z, which is z1 minus beta. But for 90% power, there is a value that you need to pick from the statistical, from the table, right? For 90% power, what is the z of this 90%? Z of this 90% is, what is the value? Like you need to select what is the value of z of alpha
And beta.
and beta, both, right? Z of alpha is the confidence level, and then Z of beta is power, right? Z of 1 minus beta. So, okay, so let me see. We have 54 students, almost. Some of them are not here. Who is not doing this exercise along with this class? Is everybody doing?
Yes, Professor.
Yes, Professor.
Okay,
Yes,
good.
Professor.
Noor Zaika, are you doing too?
Yes, Professor, I'm doing
Okay.
it.
Yeah, okay, good, good. Pooja Khanal, are you here?
Yes, Professor, I'm searching the formula.
Yeah, that's true. Sadia Islam, how about you? Sadia, no response.
Professor, the root is for the second one, the second root is for the whole equation or only for PA multiply 1 minus PA?
Okay, let me see. No, it's it's until PA into 1 minus PA, right? Not
Until
and then also there
uh,
is like, you know, there is a slash. Slash means it's like the divide all of them by P0 minus PA square, right? Slash, so division, this slash is like you divide everything. So instead of putting them underneath, so we just have slash, right? Trying to see who is not doing work. Tika Gele, are you connected?
Yes, Professor, I got disconnected and
Okay, okay. Yeah. Tahia Sarwar. Tahia, are you there? Tahia.
Professor, I got the answer of 477.
477. Okay, let us have some validation. So keep this.
Professor, I'm sorry, I was disconnected. So we are using this formula, right? The
You have to find out the
second
formula. You need to find the
Professor.
right formula.
Okay,
Yeah,
we have two formula.
we have two formula, right?
Professor,
Yeah.
sorry, I got disconnected. So, how will I get Z 1 minus alpha and 1 minus beta? I didn't understand this part.
That is a good question. How you are going to get this 1 minus?
Yeah, Professor.
So Amal, can you help like how to get this Z1 minus alpha and Z1 minus beta? Number.
Yeah, we have the confidence level. So Z of 95%, we have to look in the Z table and and see where is like 95%, where it matches. So it will match with 1.96, and for the other one is like 90% for 1 minus beta. Yeah. So
Yeah.
we have to follow.
And then for
I got
90% power, what is the Z of beta number that you
beta.
have used?
I got it 1.282.
Exactly. Yeah, 1.2 282, right? Okay, so 1.28 for 80% power, 90% power. And then
Can
for
you just repeat it? How did you get?
You look at the confidence level, for example, 90%, and you go to the Z table and you find like where is the closest number to 90%, and then you match it with the row and the column, and you get like 1.96 for Z, 1 minus alpha by 2, and you get 1.242 for Z, 1 minus beta.
Okay, thank you.
Hello, Professor. Can you hear me?
Yeah.
Professor, this is 5% of level of significance or 95% of level of significance?
95% is the power. So 5% is the level of significance relating to alpha. And 95% is relating to the beta, which is the power. 1 minus beta is the power. And 5%.
Yeah, Professor, I get it. No, I'm saying in the question too, it's written 90% power at 5% level of significance.
5%
Shouldn't
level
it
of
be
significance.
95%?
90% power and 5% level of significance, or 5% level of confidence, right?
So we usually have like 95% level of confidence, right?
It's the level of significance 5%. It's the same thing. 95% level of 95% level of significance. 5% level of significance. Okay, so I get it. What you want to mean? So 5% is the level of significance. I think it's the just follow the 5% for the alpha. Alpha is like for 5%. Level of significance 95% is actually meaning that, right? You're right.
Yeah,
so,
I get it. Like alpha is equal to alpha would be 5%, but 1 minus alpha would be 95%, right? Because if it's level of significance 5%, then it's not even a significant study to do.
Oh, okay. So I got it. So the level of significance, then we should write 95%, right? Okay, so yeah, I changed it to 95%, but it remained the same thing, right?
Yeah, I was doing
Yeah.
that and I was confused if I should put 5% for
No,
level
5%
of
you don't have
significance.
any value at all. Or what
Yeah.
is the value? That's
Professor,
true.
what is the answer? I got like 803.
You got 803. Okay, so let's
Amal,
see.
what is the Amal's answer?
477.46.
477. Is it like 1.96 times a root of 0.25? Is it like that? Bracket 1 minus 0.25
Yeah.
plus, oh, then I did some calculation mistake then. Then the second one is 0.2, right? 1 minus 0.2.
Yeah.
Oh, okay.
And then all
Maybe.
divided
Yeah,
by
all raised to 2. Yeah, divided by 0.25 minus 0.2 whole square.
That's true. Yeah.
I did mistake, I guess. Let me cross check, Professor.
Sir, I got 741.
You got 741.
Yeah.
Okay, so let's wait and see.
Amal, what did you get the answer?
477.46.
500.
7.
Professor, I got 544.6.
Okay. So you see, I just use the number instead of in the formula. So this should be the number that you should be calculating.
Professor, I got something like 488.41.
So we are getting different.
Professor, I got
Yeah.
Oh, Professor,
I
I
got
did mistake.
741.45.
Yeah, I got the same now. 741.
Okay, so 0.25 into 0.75. 0.1875 and 2.8. So now we have a little less number here, as I have calculated. Oh. .16 root .
Is it like 740.93?
We're getting different numbers.
Professor,
Hmm?
I think you missed the square.
Yeah, Professor.
0.84.
Yeah.
So yeah, I missed
The whole square.
whole square. Which one? In the below one?
No. Up.
Oh.
We have a whole square in the numerator.
Above
Professor.
one,
Whole
the
square.
numerator.
Yeah. I see. Whole square still we can. Okay. Yeah, I got it. Let's see. So inside one, I can still 1.28 into 0.4. So 0.512, right? Yeah, but I guess that we missed the square, right? So we'll add square that I have missed all the way, I guess.
Anyone with 742?
Okay, let's, yeah, anyone?
With 742.
Professor, till now this your maths with my one.
It is
Let's see
matching.
that.
Oh, that's good. I'm having confidence a little bit.
I got 740.6 as well, the best one. Yeah.
Okay, so 0.5.
Zahida and my answer is quite same.
Okay.
Yeah, it's close.
You got like, if you round up, we will get same.
Yeah,
Yeah.
0.1885, and then if you divide by 0.00.
Yeah. 25.
25, right?
Yeah.
Yeah, 0.0025. Then how much it gets? 0.1.
Same, Professor. I got same like yours, like
Oh,
0.
that's really good. 0.0025. Oh.
It's not.
Not coming. Okay.
It's not 0. It's 1.885, right? Isn't it?
Okay, let's see. Maybe there is
I
some
don't know now, Professor.
848 plus 0.512.
I just
Oh, it's
calculate all
like,
together. That's I don't know the.
yeah. Okay, so
Right.
it's like point is, there is a mistake, I guess. 8, 4,
96.
96, right? Exactly.
Mm.
So yeah, and then if you divide by 0.0025, so 739.84, right?
So you're writing in a different line.
I am right. Yeah, that's true. So
Oh,
730.
it's 740.
Yeah, that's true. 7. Okay, let's say 740. Right.
Yeah, Professor.
So yeah,
Yes, yes.
yeah. So
I guess everyone that it's been
I
740.
miss square all the way. Right.
Professor, like some of us.
Yes. I cannot hear.
Professor, is it better to keep it as a whole number?
Yeah, it is better to round it up, right? Because when it comes to individual or subject, you cannot have a fractions, right? So with 20% extra, so how much? 740 into 0.2, 740 into 0.2, 148 plus,
8%.
yeah, 888, right?
888, yeah.
Oh. Yeah. Yeah. So for 20% extra non-response, so your estimated sample size would be 888. But of course, if you see that you already achieved 740, so then you need to stop by taking few extra to to account for missing and then also inconsistency and all this, right? So do you think that this is the right calculation based on the formula?
I guess it's right, Professor.
I think it should be. Yeah, okay.
I'm doing it every time I'm getting another.
Okay.
That was my case too. But then finally I got 740.
Yeah.
Yeah, these brackets are confusing.
Yeah, I know it could be easily because of this square root and then where to stop and all this is little confusing, right? So yeah, try to do this. Probably it is right. So I'm going to share this with you. So, but I'm wondering that who has not done this along with us. This is something.
Professor,
Yes.
the root applies to only the whole thing, right? Like 0.25, 1 minus 0.25.
Yes, until this, and then another root again to second part, right?
Yes.
Yeah. Root applies to within the for the third, yeah. 0.25 and then 1 minus 0.25, this part, and then again root applies to 0.2 into 1 minus 0.2, this part, right?
Professor, look at the bracket. So the root starts from the bracket until the bracket ends very even at the last. I don't know.
I
So
think there's a confusion with the bracket.
there could be a bracket related problem also, right? So yeah, that is, it is possible. So the bracket, third bracket is not actually, it should end here. Another one is actually ending here. This is fine. So one bracket is missing here,
Formula.
right?
Yeah, in the formula, the bracket which starts from the first root is ended with the second bracket at last.
That's true. So the one bracket was missing. Now just I have given this bracket here. Third bracket was not closed here in the formula. Third bracket.
Should it be closed there?
I just close. Yeah, here. Yeah, this one. Yeah, it should close here.
Because if we close it here, it will give a different number. If we close at the end, so that should, all of them should be under this root
Yeah,
square.
I understand. So no, it closed here. That's what we did the calculation. I think we did the calculation right. Just the bracket that it was not shown one third bracket missing, but another third bracket you see start here and then also closed here. So which is fine.
Professor, I had a question.
Yes.
Sorry, Professor, I got disconnected. That's why I missed maybe. Like, some of our got this close answer like 740, 741, and some got.
I think that's fine. That's fine because you know the digit, how many digit you are considering, that may be a little bit difference between 400, 744, 740. So this is okay because the number of digit that you are counting after the decimal maybe makes this little differences. So this is fine, I think, to have 744 instead of 740. So it's not a big deal.
Okay, Professor. Thank you.
Yeah. Okay.
Professor?
Yes.
Just one question. So you said that the non-response rate, we have to consider that in the planning stage, right?
Yes, yes.
So Professor, if we are writing a research proposal, we have to write the materials and methods section. So in that section, do we have to mention the sample size along with the response rate or without?
Yeah, no, with non-response rate, because when you write a research proposal, this is still in the planning stage, right? So at this stage, you don't know exact exact rate of non-response. That's why arbitrarily we consider just 20%, right? So this 20% can vary when you actually do the data collection. But when you write a research proposal, just consider 20% as a non-response.
Okay, thank you.
Yeah. Okay, so I hope that this is a little bit useful in order to calculate your sample size. But sample size, as I said, that there might be other formulas for other kind of estimate. This is only for cross-sectional studies. One is just a cross-sectional. Another one is like one intervention that you do to change one proportion to another proportion. But these are all proportion. So there is another assignment, another question in the last one is actually not the proportion, rather another one. So let's see the last one. We're not going to do the last one, but this is another formula that you have to use. You see, the local health department is planning to examine the level of anemia among female students in a community through testing the hemoglobin level. So how many sample we should enroll in a study to estimate 5 percentage point of view precision, 95% confidence, 95% confidence level, right? And then also 80% power, and delta being 25 gram per deciliter. So this is another kind of scenario. And then you see the level of hemoglobin is not a percentage. It's like a continuous value that you will get. So if this is the case, so and then this kind of study, instead of doing the percentage calculation, you will be calculating the mean, and then the test would be t-test. On the other hand, the two sample that we have calculated, those kind of tests, we will be doing the chi-square test, and then here you will be doing the t-test, because the outcome is a continuous variable. The level of hemoglobin will be counted like as a number, continuous, as a digit, continuous number, right? So the sample formula, there are also formula for this. So based on the situation, type of study, type of outcome that you are following, you have to calculate sample size accordingly. So knowing how to do sample size calculation is a very good skill as an epidemiologist. So many researcher, they like physician researcher, so social science researcher, they want to do a quantitative study, they come to the epidemiologist and biostatistician to get help how to calculate sample size, because this is something they probably have less understanding of. So biostatistician and then epidemiologist are the one that they can help in actually figuring out that which formula they need to use, and then what are the estimates that they need to consider to come up with the sample size calculation, right? So this is a good actually skill as an epidemiologist. Good. So with this, I'm going to move on to what we actually wanted to cover in today's class. Here, this file I'm going to share with all of you so that you can follow. If you have not done this exercise along with us, I hope that you have done. But if you have not done, still you have a chance to go through and then see that how we have done this, right? So I'm going to share when we share the slide. We'll also use this one. Okay. Oh. Sorry, a little confusing. So I'm going to share is actually sampling. So I wanted to discuss sampling in today's class, right? Sample size and sampling.
Professor, on Friday when we are submitting the topic along with the sample size, are we submitting also the calculation?
The assignment on the sample size?
Yeah, for our own topic, research.
Oh, okay. No, sample size calculation is not due on Friday. Friday is only, you identify the topic, the area that you want to work, and then also the population, which population and which location. That's it. Sample size calculation will come a little later. It's not this Friday. Yeah. This Friday you are just proposing a topic and then location and the population, and another point maybe the design of the study. Are you going to do a cross-sectional study or what kind, right? That's it. Sample size doesn't come, it will come later. When you write the research method, which is the I think the third phase of your work. So what do you see on screen right now?
Population and sampling process, sample error, variation, and variables.
That's true. This is something I wanted to discuss today. So, when you know that how many people that you are going to recruit in your study, the number, then the next step is like, how are you going to recruit them? So you know the number now, but how are you going to get them? So that's sampling, right? Sampling is also very important. Like sampling, we have discussed in other classes that sampling could be random, sampling could be purposive, sampling, there are various types of sampling, right? You can choose whoever you want, whoever is living next to you, whoever is your friend, whoever you get when you get to the field, who comes in front of you. Sometimes it is some people call it random. So if you go to a community, the people that you come in front of you, some people consider this as a random people, but from epidemiologic point of view, this is not random. So how are you going to get this 484 people that you need to include in your study? That's the sampling. So this sampling in itself is an important step when you conduct a research, right? Why we need sample? Sample we need because when we plan to conduct a research, we are not going to work with everyone in the community, right? So if you want to conduct a research in a slum in Chittagong or in other city, so not everybody in a slum that you are going to collect data from. So because this is not possible, this is difficult to include everybody. So ideally it would have been better to get information collected from every person of a community of a population. But in most cases, in almost all cases, we are not going to recruit everybody, rather we deal with the sample. So that's where the sample comes in, right? And then in real life situation, we also use this sampling to see, we use sample in order to make an assumption for the whole population, right? To make an assumption for the whole population, we do sampling. And then this sampling exercise, you see in various ways that the people use apart from research as well. For example, when people do forecast about election outcome, you see that before the election day, some media that they say that they did forecast that this party will win by this many constituencies or this many percentage point. So they do the forecast, and then they do the forecast based on a sampling. So for example, when some people, they do sampling because after the voting, the people come out, they talk to 100, 200 or something, and then based on their response, they make an assumption about the whole election as a forecast. So sometimes their forecast works, sometimes they don't work, right? So that's the, if it works, then they are close to they're right about their forecast. Sometimes they make mistakes in their forecasting. But what they are working with is the number of, not the all voter that they ask about the selection outcome. They only work with a subsample, right? So in research also, we use this subsample, only part of the population, in order to make a conclusion about the whole population. For example, in your household setting, people also use sampling, right? I'm not sure that you probably also do it as well. When you cook rice, for example, people take 1 or 2 as a sample to see that how better the rice was cooked, right? Or when you do a curry, so people do test with a spoon to see whether the whole the curry pot, how it is going. It is going to be a good cook, or like the salt is more salt or under salt or something, right? So this is sampling. So you want to do a little bit to make an assumption for the whole thing. So that's exactly we do when we conduct a research. We recruit 484, but we want to make a conclusion about everybody in the community on this situation, right? That's what the sample. And then that's why having appropriate sampling is important. If you do a wrong sampling, so maybe your conclusion about the whole community, whole society will be with mistakes. So that's why doing sampling is best to do a random sampling. You pick a sample, you pick a sample which you think is a representative of the whole population. So a target population, sample population, and then sample. Sample is only this little smaller dots, and then a researcher only work with this sample, but idea is to make a conclusion about the total population. So that's what the purpose. You do the sample, but you want to make a conclusion about the situation that this disease is very high, or this disease is very low, or this risk factor is very common. Something like this, you want to make a conclusion about the whole population. How efficient is your sampling, how efficient is your result. That is the point, that whether your assumption of the whole population is true or not, right? People make mistakes in making sampling and then also other processes in order to make a conclusion about the whole population. That's why doing it right is very, very important, right? So we have around 20 minutes or so. So let's see that how much we can cover. So why, instead of doing whole population, we do sample, because it is kind of impossible to deal with the whole population. And then also there might be the bias issue. That's why appropriate sampling is important. It saves time and money, right? And then feasibility wise, it is also feasible. Otherwise, dealing with the whole community, whole population is not feasible. So representativeness is very important. You want to pick the number of people, that 484 from a population, and then they should represent the whole population, right? That's representative in terms of the 3 dimension, right? The personal level, place level, time level. Person, place, and time. So you pick your sample, the representing both, sex-wise, age-wise, and other demographic information, rural and urban. And as an example, sometimes people do one-day research in the rural area or in the urban area, which is fine. But place consideration is one of the dimension of representativeness. Time, like which time of the year. Sometimes that you conduct a research when disease prevalence is naturally very high. So and then other times is very low. If there is a seasonality issue, is so commonly dealing with this particular disease, so you have to do in a time when seasonality effect is minimized. So, but that's why the timing is also important, right? So if you conduct a research about flu in the month of December and January, so depending on the geography, you might have higher rates compared to if you do it in June and July. So if you conduct in January and then make a conclusion about influenza for the total year, may not be a good thing. So seasonality representation is also important. The timing, when are you going to conduct your research? All these things. So there are definitely some definition. Population is the whole group. Sample is a subsample, right? Sampling frame is something is also important. If you want to conduct a random sampling, so sampling frame is important. Random sampling is only done if you have a complete list of people that belongs under a sampling unit. So you have to have a total list of people so that you can efficiently do a random selection. So without sampling frame, random selection cannot be done. You have to have a, yes. Tanveen?
So Professor,
yeah, go ahead. Oh, we cannot hear, sorry.
hello, Professor, can you hear me?
Yeah.
Yeah, okay. So what I'm saying is, the random sampling, can it be done in a public area? Like,
how?
You know, you said like in order to have a random sampling, we need a unit,
Sampling
or
frame,
a list
yeah.
of people who with
Yes.
maybe, yeah. So random sampling cannot be done in a public area, that means.
You can do it in a public area, but you have to have a list of the people that belongs to this area.
Oh, that means we cannot really say that these people belong to this area, right?
Yeah, then so then this is not a random. This is like a convenience sampling or purposive sampling. Convenience may be the right word. That if you go to a public place and then like the way that the journalists that they pick people to have an interview when they report to their television or news media, they pick someone from a crowd and then ask, what is your feeling? So this is not a random sampling, even though it looked like a random that they pick someone randomly, but this is kind of a convenience. You see that within this this selection, the reporter still have some bias. They select someone that they like or they thought that they can give a better response, right? So they try to pick someone who is kind of educated or I don't know, some sort of personal likings play a little bit twist when they pick someone as to report something in a crowd, in a public place. So, but from epidemiology point of view, this is not completely random. So you have to have a list and then you are completely blind who is going to pick. That you give this picking responsibility you give to someone else as a computer or some other random draw. Then you have total, you don't have any control that we're going to pick. Yes.
What about like, for example, okay.
Okay.
No, Dahida, carry on. Yeah.
Okay, go ahead.
Okay. Random sampling.
Zahida, we cannot hear.
We have the listed population. Among them, we will be select blindlessly, right?
Yeah, for random selection, you need to have the list of people that from where you will get random selection. Without this list, random selection is not possible.
Will be we have the listed population, then among them we will select randomly.
We will select, but you are not going to select as an investigator. You rely on a process to get people selected randomly. So
like lucky draw?
From a lucky draw, or you ask the computer. So there are software like in SPSS can also do, Stata can do, Excel also can do. You see that you will say that, okay, I have list of 1,000 people. So give me 179 picking randomly. So there are ways. So you need to say that I have list from 1 to 1,000. So give me 195 list, 95 person to me. So the software will select you, or you will do the lucky draw. In pick number 1 in one piece of paper, fold it, put it in a jar, and then you put 1,000 of them, and then you ask someone to pick one by one until you reach 174, for example, your sample size, right? So that's the random selection. But for that, you need to have a list of people somewhere in the computer or in a lucky draw box or somewhere. You have to have this list. Otherwise, it is not random. So as I just said, if you go to the public place and pick someone which is not random, which is based on convenience, because there are some bias that works when you select someone, right? So this is not totally random from epidemiologic standpoint, okay? So sampling error and the sampling variation, these are also terms comes along with this sampling. Sampling error is something, the difference between the sample statistics to be estimated in the population parameter and then actual the value of the parameter. So if you even do sampling, whatever the type that you use, random or others, there might be still some error that might happen. It may not be completely representative of the population, even if you do a random selection. random selection can also make some error reflecting the actual value in the total population, right? So that little mistake that you need to accept even if you do random selection. So sampling variation is there because the population level, people are different in terms of their age, in terms of their geography, in terms of their genetic construct. So there are variation. So that's why if you do sampling multiple time, so here is an example. In a clinical trial of 200 patients, so if someone randomly selected 200 people and then you find a efficacy of a drug 75% effective efficacy, right? So this is a study someone did. So with the same population, if a second investigator conduct another sampling, pick another 200 patient and conduct the same drug, everything, so it is possible that to get the effectiveness efficacy level of 77% or 73%, right? So if you repeat the same research with 200 people collected randomly again another random selection of people, another person randomly select another 200 and do the same study, same drug, everything same, still the efficacy could vary a little bit because the 200 that you have selected at first point, another 200 or some of them again comes in the second sampling, so they are a little bit different. So this is something because of the sampling variation, right? So the sampling variation is there. So that's why in statistics and in research, so having little bit of flexibility is there to accepting a true result. So if you find 75%, another person find 77 and 73, so little bit of variation is accepted because the level of confidence and the level of the all other estimates are not 100% all the time. There are scope of accepting a little bit of variation, right? This is because the true population, there are real variation is there. So which is okay. As long as you see that when we calculate the sensitivity, we are happy if we have 90% sensitivity or specificity of a drug in a screening test, right? We don't expect that to be 100% because 100% is very difficult. So this is a process of doing sampling. Define the population, determine the sampling frame, select the sampling technique, random, purposive, and determine the sample size, and then do the sampling. So this is how it works, right? So for sampling, there are two basic types. One is the probability sampling, another type is non-probability sampling. Probability sampling is also called the random sampling, right? And the non-probability sampling called the non-random sampling. In the probability side, you will see still there are various types. One is like the simple random sampling, stratified random sampling, systematic random sampling, cluster random sampling, multi-stage random sampling. All are random, but there are still variations, right? So, and then non-probability sampling is also various types is possible: convenience sampling, purposive sampling, quota sampling, snowball sampling, consecutive sampling. So have you heard of all different kind of sampling names?
Professor, what is about quota sampling? I don't understand this one.
Quota sampling, others you have understood?
I read the chapters you sent, but I could not get the quota one, and then persuasive is also better.
Yeah. I think
snowball also.
Yeah.
Like it's like it's setting a proportional sampling, like proportional goals, and
yes.
We have like based on the sample specific characteristics.
That's true. So for example, quota is something like if you said at 20%, you have to have from one district, another 30% from another district, another 30% from another district. So if you set a criteria that you have to have sample coming from a certain percentage from certain group, like quota sampling is possible by men and women, boys and girls. You have to have 50% boys, 50% girl. So that's the quota that you are setting. So you cannot do just exactly random selection where you might get all boys or all girls, right? So, but you want something to see what happens between boys and girls, so that you have 50% there, 50% there. So that's kind of things are quota. You set a criteria in order to get sample, right? Which is something needed, right? Because if you just rely on random sampling, it might end up having 79% boys and 21% girls. So your comparison may not be with equal strength. That's why you want 50-50 or any other percentage for the district, for example, the provinces. So if someone conducts a national-wide research and then they want, based on the size of the population, they can say, okay, 50% from city of Kabul, 20% from another city. So you have to maintain this quota, right? That's the deliberate sampling or quota sampling. So yeah, Diana, you raised your hand.
Yes, Professor. So I was asking that, if, for example, if we didn't focus in the gender and we just collected our data randomly, and then we realized that there is a kind, not really bias, but like there is more about the male, but less research on female, then.
So that's possible. That's the surprise that you will get if you see that there are real variation between boys and girls. But as a researcher, you have to have a hypothesis before you start your study, that do you care about this variation between boys and girls? Is it so important? If it is so, then you plan accordingly to have both boys and girls representation. But for some health issues or some other issues, that this variation among boys and girls are not that important. So in that case, so you just go for a random sampling, because gender is not very important in some situation. This is possible, right? So yeah, Tandin.
Professor, my question is like, for example, now it's about the sample. So if the sample, the one, I mean, like the participants doesn't really give us information that we are looking for, then what should we do? Should we change our way of doing sampling?
No, you don't change your sampling strategy. So if for example, your sample size is 295, and then people you went to the field, and then people don't want to give information, so you keep trying until you reach your the number. So but sampling, you don't change unless it is so obvious to change, right? Yeah, so that is why before conducting a study, you need to do a little bit you thinking that which sampling that we are going to follow. Of course, the simple random sampling is the best, but this is the toughest thing to do in a study, right? Even though this is the best way to go for it, but this is difficult because of the thing that you have to have the whole list of the target population in order to do the simple random sampling. But this simple random sampling is possible in a hospital setting, when in a ward, this number of patients that are admitted is listed somewhere in the doctor's list, in the admission list, right? That list is available. Then you can randomly choose that bed number 3 comes, bed number 7 comes, bed number 39 comes. This is possible because you have the whole list, and then this is a limited number of lists. You can do simple random sampling in a school, where in the headmaster's office, they have the list of all students. So if they cooperate with you, you can get the list of all students in a school, or by class wise, class level 10 versus level 11. So they have the whole list. So you can then randomly select 15 from each class from the list if they give you. So this is possible. But if you want to conduct a simple random sampling in a slum or in a village, so if you don't have the complete list of people, so this is tough, right? This is difficult. Sometimes this list is possible for the national level research. So they collaborate with the statistics department of the country. So when in the last census or something, they still have the list of people. So if it is a so important study that the national level studies, everybody cooperate. So you can have a list from the Ministry of Statistics, I don't know. So that list is also possible, but depends that which level you are collaborating and how important the country, and then people are willing to do it or not, right? So all different kind of things could be considered. So let's, yeah, simple random sampling, just we have considered. So techniques of doing simple random sampling, you have to have a list, and then you either do the lottery or random tables, random number generator through computer or other software. They can give you the random number they generate, right? If you see, have you seen the one of the, I don't know, okay, so housey, I don't know what's the term that the people do gambling or something. So there is a number and then someone rotate this and then pick a number comes up, right? So and then they said, oh, the number 39. So then people mark it in their sheet. So those kind of any number generator, those are some of the ways that you can do simple random sampling. This is the most representative, this ensures the representativeness, but this is the difficult sampling method, the most difficult one, right? But that's the, yeah. So you have to have all these things. The 4th grade boys who have demonstrated, right? We don't have time, right?
Yes, Professor.
Okay, we will continue in next class if needed. Okay, I'm going to stop it here. Yes, so you know because of this exercise that we have done, taken a lot of our time. So yeah, I'm not going to.
But it was good, Professor. We understood.
It was good, right? Yeah, that's true. It was actually a good exercise. So I'm also going to share the calculation that I have noted here in the sheet. So you can have an opportunity to see this, right? So we'll come back to this sampling in next class and then try to complete, because this is an very, I mean, to me, it's very interesting that how do we sample people, and then there are also a lot of misconception and then also the wrong information that we might have. So as a public health student, public health practitioner, you have to have as much as possible the good idea about this sampling as a process of research, right? So I mean there are a lot of the different kind of wrong concept are there. So people do them, but still they think that they are doing right. So this is something we can clarify and discuss, right? So the thing is remaining is attendance.
Yes.
So can we quickly do this? And then if you are done with your attendance, you might leave. Okay. So who is going to take attendance today? Chetan and Tazri, who is here?
Sir, it's me. I will take the attendance.
Okay, Tazri, go ahead.
Okay, girls, I will call out your names. Please respond fast. Mame?
Present.
Present.
Rachana?
Present.
Padma?
Present.
Halima?
Present.
Tandin?
Present.
Nankai?
Present.
Roshnai? Roshni? Ashlyn?
Present.
Asmaul Husna?
Present.
Mithila Chakraborty?